Good morning, good afternoon, good evening, ladies and gentlemen. In today's video, we're going to be looking at the trig ratios of special angles. Now, the special angles usually have to do with two separate triangles. Now, I'm going to do triangle per page here, just so that we can be able to understand where we're going with here, okay? And so we can have some nice room. So, in this triangle, we're going to go with the 90, 45, 45 angle there, okay? Now, let's say here I don't know what any of my sides are here. So let's use some variables. Now, if this is 45 degrees, whoops. So if this is 45 degrees and this is 45 degrees, what does this mean for our sides? Well, if it's 45 degrees, then that means this line should be the same as this line in length. I don't know what either side are, so I'm going to give them the variable x. Okay? Now, this is a right angle triangle, and if you're ever missing the third side of the triangle, remember we have this beautiful formula called Pythagorean theorem. Okay? So Pythagorean theorem says that you should have a squared plus b squared is equal to c squared. Now, just in case you forgot what these are, the c squared is always going to be belonging to your hypotenuse. That's the only one that can't ever change. But your a and b, it does not matter whether this is your a or this is your a, or this is your b and that's your b. Doesn't matter. What matters is this side here will always be your C. So this is my C. Okay? So if I put these into the formula, I'm going to end up having x squared plus x squared is equal to C squared. Well, I have x squared plus x squared. These are like terms. Why? Because it's the same thing as me saying 1 apple plus 1 apple should give me 2 apples. Okay? And then if you wish to figure out what c is, because obviously the hypotenuse is c, not c squared, you need to take the square root of both sides. Now remember, just as an aside here to remind you of something, when you take the square root of two terms, it's the same thing as saying the square root of the first term multiplied by the square root of the second term. Okay? Which in this case, obviously, I can't do anything with root 2, but the square root of x is just x. So, this in reality, so c should be root 2 multiplied by x. Okay? So let's make an example here. Let's say I told you that this side here, this x is 1. So if x is 1, then this should be root 2 times 1, which is equal to root 2. So you can see the special angle here would be 1, 1, root 2. Okay? So we're going to be taking a look at the next special triangle, and that is the 30, 60, 90 triangle. So let's take a look at that. Okay, so let's take a look at our second case here. Now remember, these are called special cases because no matter what triangle you're looking at, it's always going to follow that rule of root 2 times x and x times x. Now, if you're looking at the 30, 60, 90 triangle, the best way to take a look at this, let's say I don't know what my h is, or my hypotenuse. Let's call this h. Okay? Now, an interesting thing to try here is to extend your triangle. So I've extended my triangle successfully. Obviously, you should be using a ruler here. do. Okay. Yep, horrible drawing, sorry. Now, obviously this would also be 90 degrees. This would also be 30. So let's say I duplicate my triangle, so this would also be 60. Well, what do you notice here? This whole bigger triangle, if I'm looking at the bigger triangle, the whole thing, well, this would be 60. The bigger angle there would be 60. This is 60. And this is 60. What did we learn before? Well, if they're all the same angles, this also means that this side should be equal to this side, should be equal to this side. So, if this side is h, then this side should all be h. And this side should all be h. So if they're all h, then half of it should be h over 2. H over 2. So we found out 2 out of the 3 of them. So now we're just missing this side here. So let's go back to that separate triangle here. So now you have, I'm just going to draw this by hand here. Oh, terrible. Folks, always remember to use a ruler. Don't be like your bad teacher right now. Alright, so this is h over 2, what we discovered there. This is h. We're missing this. So if I'm using Pythagorean theorem again, well, I don't know what a squared is. Again, it could also be b squared. It doesn't matter. I know my b squared or my a squared is h over 2 is equal to h squared, because that's my c. That's my a or b, doesn't matter. A or b, doesn't matter. So if I want to solve for this a squared, I'm going to need to move this h over 2 squared to the other side, which is going to end up giving me a squared is equal to, well, if it's plus here, it's going to be minus here. Okay? So I'm going to actually continue it in this section here. So you're going to have a squared is equal to, let's simplify this. So you're going to have h squared minus, well, let's actually do the squaring here. So h squared over 4. This is the same thing as saying h squared over 1. So you're going to need to multiply the top and the bottom by 4, common denominators. Now that they're common, you can actually do that on the top. So you have a squared is equal to 3h squared over 4. Then you want to get rid of the squared. So you're going to have a is equal to, well, once again, as on the side, remember, root 3 times root h squared. So you're going to have root 3 multiplied by h. Same reason as what we looked at in the first page, divided by square root of 4 as well, which is 2. Okay? So that means this side here should be root 3 times h over 2. Alright, now these special angles work every single time. So let's look at another slide here, and I'm going to put this in the table. Okay, so I just badly drew the triangles again here. So let's say we want to try to do this for trigonometric ratios, okay? So if you want to do this for trigonometric ratios, so let's say you make yourself a little table here, theta. And let's say I have sine theta, cos theta, and tan theta. Sorry, some technical difficulties there. And tan theta. Okay, and let's say we have these angles here of 30 degrees, 45 degrees, and 60 degrees. So remember, 30, what's sine? Sine, just remember SOHCAHTOA from the first lesson. So sine should be opposite over hypotenuse. So if we're looking for 30, we're looking right here. Right. Okay, so that means if I'm looking for that, so 30 degrees means I'm looking right here. So 30 degrees, that's opposite over hypotenuse. So opposite over hypotenuse. So let me just put this on the side so I can have some more room here. So sine of theta, which in this case is 30 degrees, would be equal to opposite, which is h over 2, divided by hypotenuse. Now remember, this is also the same thing like saying h over 1. So this would end up turning into h over 2 multiplied by, remember, if you're divided by a fraction, it's the same thing as multiplying by the reciprocal. H's will cancel out, giving me 1 over 2. So sine theta, when you have 30 degrees, is 1 over 2. So I want you guys to pause the video at this point, and I want you to try out the other ones. Once you've finished, I want you to come back and see whether you've gotten the right answers. Okay, assuming you paused at this point, now you're back. So let's continue on with our sine here. So if you're looking at 45 degrees, once again, now at 45 degrees, you are looking here. Now when it says 45, it could be either one. You're going to get the same thing. And remember, it's still going to be opposite over hypotenuse. Opposite over hypotenuse. Doesn't matter which one, you're still going to have x divided by that. So you're still going to have sine, so let's say sine 45, it's going to be x divided by root 2x. Well, the x's are going to cancel out, and you're going to be left with 1 over root 2. Now, as we remember from the last unit, we don't like having a radical on the bottom. So how do I get rid of this radical? By multiplying the top and the bottom by that very radical, which will end up getting me root 2 on the top, and on the bottom, root 2 times root 2 will give me 2. So 45 degrees should be root 2 divided by 2. And lastly, and but not least, 60 degrees. If we're working with 60, we're back over here. 60, you're going to do opposite over hypotenuse. Okay, so opposite hypotenuse. So you can guess how that's going to go. Basically, your h is going to cancel out, and you're going to be left over with root 3 over 2. Okay, cosine of 30, so I'm just going to go straight through them at this point. So cosine of 30, you're going to be going adjacent over hypotenuse, so adjacent being this one over hypotenuse, boom. So once again, your h's will cancel out, and you're going to be left over with root 3 over 2. So at this point, I'm just going to be writing down the answers. If you want to have some questions on how to do the work still, please let me know. So I'm just going to populate this table now. Okay. All right, and that is your primary trig ratios list summarized below. And that should always be true. So if I tell you sine of theta, sine of 45 degrees should always be root 2 divided by 2 no matter the situation. Tan of 45 degrees, and no matter the situation, should always be 1. Okay, so let's see how this will work in a simple example. Okay, so let's take a look at these examples here. So I want you to determine the exact, and when I say exact, I mean no decimals. Which basically means stay in fraction form. So basically your first step should be what? Substitute for each one the ratios we figured out before. So substitute, so change each expression for their special ratios. Okay, so I know from before sine of 45 degrees should be root 2 over 2. It's being multiplied by cosine of 45, which I know is also root 2 over 2. How convenient. Plus sine of 30, which I know is 1 over 2. And sine of 60, which I know is root 3 over 2. Okay, so root 2 times root 2 should give me 2. 2 times 2 should give me 4. So I should have here 2 over 4. Plus, over here, you're going to be multiplying these out, and you're going to have root 3 over 4. We have common denominators, so I can just add them right away. So that's going to be 2 plus root 3, sorry. I can't add them because they're both different terms, over 4. I can't go further here, and I don't have a radical on the bottom. My bottom is great, my top is great, it's simplified, so that is my final answer. Okay, I want you guys to pause the video at this point and try out the second one yourselves. Obviously, second step here, I didn't actually write it, sorry, is to then use BEDMAS to solve. Okay, so if we're solving out this one, once again, change your terms. So I should have 1 minus 1 in this bracket, multiplied by 1/2, minus 2 times, well, sine of 45. Sine of 45 is root 2 over 2. Should give me, well, 1 minus 1 is 0. 0 times 1/2 will also be 0, minus, these 2's will cancel out, giving me root 2. So my final answer would be negative root 2. I hope that has helped you guys with the special triangles, and as always, she'll do it for this lesson. Have a great day.